Factor analysis, now it is clear to all of you. Still now any doubt about factor analysis? Is it clear? Factor analysis is clear to all of you, or still now any doubt?
Sir, I couldn't run the code yesterday. I was stuck in second line.
Second line, why?
Sir, I don't know.
So after the end of this session, I will definitely answer your question why there is a problem. So
Yes, so there was one line like the DA library within the bracket having HAVN, so I couldn't run that. Due to which I couldn't run all the remainings also. I downloaded this library PSYCH. I don't know what is the pronunciation. I installed the package
HMISC.
and I yes
Yeah, I
sir.
also don't know
I
the pronunciation. The name is HMISC.
yes sir.
The problem of
Actually yes sir. Then I ran that. It ran successfully, but then second line I couldn't run.
after the end of this session, I will definitely see your screen so that the problem can solve. Fine.
Okay sir. Okay sir.
So
Yes, sir.
right now we start today's topic, basically the conjoint analysis, and nowadays it is a very good tool for marketing. Those who are from marketing or market research. Not only that, in the different social sciences also uses this conjoint analysis. Why? Because what is the research question for this conjoint analysis? To what extent does each component or factor contribute to the total utility of a product? So conjoint analysis basically developed for marketing analysis or the market research as a market research tool. That's why product is there. But nowadays you can find out or calculate the total utility of anything. So first of all, what is total utility? What it means? So basically, this is a concept of economics. Those who are here from economics background or MBA background, you are aware of the term of utility. That is nothing but the satisfaction derived from any commodity. When you buy something, when you consume something, and you try to uh, buy, or you are willing to buy something, that means after buying that particular product or commodity or service, rather, you enjoying some satisfaction. So that satisfaction is actually termed in economics theory as utility. And the total satisfaction means total utility means the total satisfaction derived by an individual after consuming any commodity or service. But the research question is to what extent does each component contributes. That means when you buy something or when you willing to buy some product, you always think different features of the particular product. So on the basis of these different features, what is the objective? Objective is each to find out the utility of all factors, and the second is, you see, the assumption is total utility sum of partial utility. So what it means partial utility? Partial utility means the utility of each features or each components. So the basic objective of the conjoint analysis is to derive the total utility as a whole, as well as the partial utility, or in literature what is called part out utility. So what it means by the factor, or what is the meaning of this component, how we derive, how we determine who are the components for a particular product or product, that actually depends on the domain knowledge. And when a company willing to launch a new product, or the company have a existing product in the market, but due to certain reason the product the market share of that particular company is declining, in that case, in that situation, the company uses conjoint analysis to find out the part of utility. And according to this analysis, they modify their product and they relaunch their product in a new form. If you follow any FMCG product, if you go to any white good products, in that case, you see that when the product initially launched and after 2 or 3 years, there is a certain differences in the features of the product. They add some features, they deduct some features from the product. Why? Because of this type of analysis is behind the particular thing. So if we consider an example, I think that is easy for you. Suppose you are willing to buy a washing machine. Can you say what are the features you can consider for that? When you try to buy a washing machine, what are the features you look? Somebody who start watching within Amazon or Flipkart, what are the features you consider for buying that particular model? Please, can anyone say something? What are the features? All of you are using washing machines. So when you buy that washing machines, what are the features you consider?
The brand of the washing machine.
Brand of the washing machine. Then only the brand.
Capacity of washing machine.
Fine. Then
How much
Whether
water
it is
will be consumed? Semi-auto,
that is
auto-related.
water consumption, another thing. Then
front loading and top loading.
front loading and top loading, that is a loading style. Then one of the major thing we are missing, current consumption. It is 3-star or 5-star. Anything else? Suppose the washing machine company know you search for this. So what are the category? You always search, it is a full automatic or semi-automatic. So some individuals are willing to buy a full automatic machine. Once you put all things, soap, the clothes, see it automatically drying this, and after that completely the 20 or 30 minutes, the whole process completed. Someone are in favor of semi-automatic. So this category is the one attribute of washing machine. And under this category, there are 2 levels. One is full automatic, another is semi-automatic. Similarly, rightly said by Mr. Amor, capacity. So you can buy 6 kg, 8 kg, 10 kg, depending upon your family size. Then the madam said, write the loading. Is it front loading or top loading? Next is the energy. That is the current consumption. Is it 5-star or 3-star? And another thing is the price. You have to pay for this. That is, here in this particular case study, I am considering 3 price. Less than 10,000, 10,000 to 15,000, 15,000 to 20,000. And the last is most vital. That is the color. The color of the washing machine. It is either white or black or silver. Basically, if you go to buy a washing machine, in maximum time, you are not willing to buy a white machine because it become, the color is not quite good after some days. So always you prefer the dark color. This is black, or someone is preferring the silver color. It look very good. So this category, capacity, loading, energy, price, and color, these are actually the attributes. And among these, for each attributes, there are levels. So category have 2 levels, capacity has 3 levels, loading 2 levels, energy 2 levels, price 3 levels, color 3 levels. Right? So what is the objective of the study? To find out the total utility as well as the part of utility. That is utility for full automatic, utility for semi-automatic, Similarly, all utility for the all levels as well as the attributes and the total utility from this particular features of the product. So the market research team of the company, after studying or some basic using basic concept or talking with some individuals who are going to the store to buy the washing machine, determine these are the attributes. And on the basis of these attributes, they want to study which features actually attract the consumer. And accordingly, they modify their product and their advertisement focuses on that particular things. So if from the survey, it is determined that in North Indian area, the individuals utility derive mostly from the color. So they concentrating more on color and then on loading capacity, then on capacity. So there is a ascending order or descending order of the attributes. And according to this, the company will modify their product, deal on the new model, assigning the features, highlighting the features which from which individual perceived to derive more utility. This is a individual derived, not perceived to individual thinks he can derive more utility from this particular feature. And after consuming, he actually deriving the utility. But when you try to when you try to buy a product, when there is a willingness to buy a product, you automatically think about the utility, about the satisfaction you derive. That is the perceived utility. Clear? So what is the objective? Once again, the objective is to find out the utility of all these attributes along with the levels. So to what extent does each component contribute to the total utility? So that means the sum of partial utility. So objective is to find out the sum of partial utilities. So now if we consider this particular case, see how many levels are there. For the time being, we are considering here 6 attributes. Among these 6 attributes, 3 attributes have 2 levels and 3 attributes have 3 levels. So if we consider suppose we consider 5 attributes. Suppose we consider these 5 attributes: category, capacity, loading, energy, and price. And for this 2 level, for capacity 2 level, sorry, we consider here 3 levels. For loading 2 levels, for energy 2 levels, and for price we consider 3 levels. So altogether there are 2 into 3 into 2 into 2 into 3, that is 6, 12, total number of 7 to 2 combinations of these levels are available. So when you try to calculate the utility or the part for utility, you have to collect data on 72 different combinations. What I mean by combination, suppose there are 3 levels, A, B, C. And what are the combinations for these 3 levels? One is AB, BC, AC. These are the combinations. if we consider 3 levels, ABC, so these are the combinations. One can say the combination may be right like here, like this, ABAC, BCAB. You can write any type of combination here. Just like this, if we consider 2 levels for category, 3 levels for capacity, 2 levels for loading, 2 levels for energy, and 3 levels for price, altogether we have to derive 72 combinations. And you have to collect the preference ordering or the perceived utility by a consumer for these 72 combinations. For these 72 combinations. So if we, what I mean by these 72 combinations, suppose one of the combination for our example is full automatic 6 kg 5-star white. So we are not considering color. Full automatic 6 kg 5-star front loading less than 10K. The second combination is full automatic 6 kg 3-star front loading less than 10K. Like this, there are 72 combinations. There are 72 combinations. So what is how we collect data? For each combination, you have to collect the satisfaction or the perceived satisfaction from a consumer. Suppose you go to the consumer and with a questionnaire which contains 72 these type of combinations and ask him, please read this different combination and give marks out of 100. Give marks out of 100. So for conjoint analysis, the most vital task is to collection of data. Why? Because it takes more or less 40 to 45 minutes to collect data from one individual. Why? You have to read all 72 observations, 72 combinations. Then he thinks, he gives some marks out of 100. So first he read this combination, give some marks. Then he read this combination, he gives some marks. Like this 72 combinations are there. So if we consider here 5 attributes, if we consider 6 attributes, if we consider the another attribute 6, that is 3 more, then what happened? Number of combination increases 72 into 3, 216 altogether combinations. So you have to ask regarding the perceived utility of 216 combination. So, and really it is very tough. So how we collect data? If I give this questionnaire to you and your task is to collect data, it is very problematic to collect data for this particular example. So you stop your research? No. So in conjoint analysis, we are basically dealing the model which is choice-based conjoint analysis, CBC. And under choice-based conjoint analysis, there are 2 types of model. One is full model. This is the full model. And if you use the full model, the survey technique or the survey procedure is very tough. What is the beauty of the mathematics? Mathematics help us to reduce this number of cards. Using mathematics, we can reduce this card from 216 to 8 or 18 or 32. That means we can able to reduce the number of combinations. Why? And the method by which we reduce this is termed as fractional factorial design. Fractional factorial design. Fractional factorial design. Fractional factorial design. And when we use this mathematical concept, we basically what we do, we try to derive a orthogonal design. The fractional factorial design is basically a orthogonal type of design. That I told you in yesterday's class, what is the meaning of orthogonality? That is, each factors are independent. That means if we use this orthogonal design or fractional factorial design and we derive L8 orthogonal design or L18 orthogonal design, that implied the 8 combinations are independent to each other. If the combinations are independent to each other, if the combinations have no intercorrelation, that means the data we collect from the consumer is a good one. And the analysis or the output actually giving us the optimal result. So you can use L8, you can use L18. There is a huge mathematics behind this. That is according to your number of levels, number of attributes, what should be the optimal number of cards or the combination. In literature, it is called as cards. What is the optimal number of cards? But with the help of software, software automatically calculate the orthogonal design and the number of combinations. So on the basis of the implication of that any software, you can use SPSS, or today we use R. This software automatically calculates the numbers of cards using the orthogonal design. You have to justify that only. And the process is known as fractional factorial design. So first, we have to learn today, because this is the fundamental thing to perform a conjoint analysis. So first, you have to define the cards or the combinations. So first, you set the cards, number of cards, and the combinations. And after getting that combinations, your main work start, that is collection of data. So as long as you are not able to form these combinations, you are not in a position to collect data. So the conjoint analysis, whole conjoint analysis research is divided in 2 parts. The part 1, using fractional factorial design, fix the number of cards and the levels of each card. This is the first task. After deriving that, you ready your questionnaire, go to the market, collect information regarding the perceived utility, and then you are in a position to find out the part or utilities or the total utilities that actually your objective. Clear up to this part, or any query, any question? Up to this part, it is clear. It is clear up to this. Please say something, either yes or no.
Yes, sir.
Joita is writing yes. Only 2 out of 15. Up to this, it is clear or not? Can I move
Yes,
forward?
Yes, sir.
Sure, sir.
So to perform conjoint analysis, you have to install the package Conjoint. So first you install the package Conjoint. Install the package Conjoint. Then call the library using library function or require function. In this example, we are considering 5 category, 5 attributes. The first task is using fractional factorial design or orthogonal design to determine the number of cards and the combinations. The function we use here, expand.grid, that is under conjoint library. We name this as experiment, that is the exp. The function is expand grid. And what we write here? First we write the category using the vector notation, 2 levels, full and semi. So category have 2 levels. Capacity, 3 levels, 6 kg, 8 kg, 10 kg. Right? Loading, 2 levels, front and top. Price, 3 levels. And energy, 2 levels. Just copy it from chat box and paste in our script. Copy from chat box and paste in our script. It's okay to all of you?
Yes, sir.
Yes, sir.
Right? Now use the function CA factorial design. We just copy the line number 11. Name the object at design. CA factorial design. Data is, that is the EXP experiment. And type is orthogonal. We are not mentioning the cards. We just see first this. We are not mentioning the cards. We don't know how many combinations is possible or optimal for this analysis. We don't know this. So after running this, if we run this design, this CA factorial design. C is lowercase a factorial design. Then within bracket data, name the data file. Here we are using an EXP and type is orthogonal. Right? You see, these are the designs. Semi 6 kg, front, less than 10K, 5-star. The combination 1. Semi 8 kg, top, less than 10K, 5-star. So these are the combinations. And altogether, if you count these, 20 combinations are there. So always, when you use this orthogonal design, if you already know, suppose there are willing to, there are the 18 cards. So you get actually total 20 combinations. So 2 dummy combinations are there. That is a holdout. In literature, which is termed as holdout case. So 18 is the actual case and 2 is holdout case. And if you count these altogether, 20 observations are there, 20 combinations are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Up to 50 or 15, 16, 17, 18, 19, 20. So 2 holdout and 18 combinations. So if you don't know anything, you just simply run this. So software automatically calculates the optimal number of cards. And with the help of mathematics, you know what is the optimal number of cards. Then you have to write the line number 10. Cards is 18 and use the seed command. It starts from 1 to 3. Suppose in R, you want to know anything about the function. You use this particular notation, line number 13. Single question mark, CA factorial design. If you know the function name. If you don't know the function name, then you use double question mark and the what you want to know. R automatically gives you the help file of that particular item. So I will show you, if you run, suppose you don't know how to write this CA factorial design function. What is actually the arguments for this function? You just run this. You just see help file. Function factorial design case food or factorial design. What are the arguments? Data, type, cards, seed. Clear? Types are full, fractional, CA, SCA, orthogonal, default value type, null. And also some examples are given here for your practice purpose. Clear? So if you follow this method, for any statistical analysis, no help is required from anyone. You automatically able to run your code. That is the beauty of this R package. Different examples are there. Clear? Similarly, if you know the package name, but you don't know how to use that package, suppose we are using here Conjoint. Just click on run Conjoint. Taking some. So no documents for Conjoint in specified packages and libraries. You could try double question Conjoint, right? You see what happened? R is trying to find something for you. You just see. These are the pages available about Conjoint. So you can search anyone. So function conjoint, sample data, these are the data available for your practice purpose. Clear? How to learn, how to use R for your self practice and self study. So now back in the conjoint analysis. We define design. Now we use the command line number 14, print design. So when we print this, the same thing appears. The command is same, but what you see, these all are characters. As I told you from the first class, that if the data is in character form or text form, you have to convert this in a quantitative form. Otherwise, you cannot able to perform any statistical analysis. That's why we use this function, line number 15, CA encode design. That is, if you use this function, it's automatically encoded your design. Automatically encoded your design. So code, this is the object name for this function. I am using a code, sorry, and CA encode designs is the function name. CA encode design. And what to encode here? That this design that is already derived by using orthogonal process. So if we run this and print this, you see, this is the code along with this. So two categories, semi and full, is coded as 2, 1. Capacity, 3 categories, 1, 2, 3. Loading, 2 category, 1, 2. Price, 3 category, 1, 2, 3. And energy, 2 category, 1 and 2. It automatically creates the code for each level. Right? Up to this, it is clear? All of you able to run this?
Yes, sir.
If not, I will give the code in chat box.
No, we haven't received the code. So
I am given this in chat box.
No, sir, you have given only up to energy equals to C.
Oh, the first part I am giving right now, giving this.
Okay, sir.
If you're not able to write from the scheme, you just copy and paste this. Clear up to this?
Yes, sir.
So now you're factorial designing ready. You are in a position to collect data. So from here, with these cards, you have to make a questionnaire so that you can collect data. For this, we make these two design and code at the CSV file. So you already know how to write CSV, use the function write CSV. So I am using the command write.csv design. I save this, the file by name orthogonal auth, and the code as a CSV file code. Clear? So if we write this, use this number 18 and number 19, you have to write your own path. Don't copy my path. Write CSV, the design, then file equality, you use your own path. Write CSV code, you write your own path. So after executing these commands,
Excuse me.
please.
Is it actually always better to have CSV file for operation in R? It's better to have it in CSV format, na?
Not necessarily. But if you make a CSV file, then you can use anywhere from the CSV file. Actually, Excel is not the data file or database. CSV is the database. So that's why
For the purpose of R, if we have the
not for
CSV,
the purpose of R. If we consider a database, a CSV extension is a database extension. Excel is not a database.
okay.
Yeah.
What
That
I'm saying is,
I read in literature. I also in doubt about like this. Why we always save in CSV format? So the literature actually gives us the idea that .csv means this is a database.
that means there is no comma, no full stop, something like that.
Yeah, yeah. So once you save this, you see two file saves, auth and code. You see in your system, automatically in desktop, two file saves. But these two files is not showing as the CSV. So what you do, if not showing, if it shows .csv, it is okay. If not, you just simply rename it. Simply rename it by what? Or you just write .csv. Clear? So automatically it's create a CSV file. If we write code here, rename this is your CSV file, which contains the all cards, altogether 20 cards. And see, altogether 20 cards. You just see. Check this, count 20. So 18 and 2 for holdout. And what are the numbers here? 2, 10, 12, 15. What I told you, altogether 72 combinations are possible. So among these 72 combinations, the 18 combinations and 2 holdouts derived using orthogonal transformation. And what are the numbers of that cards? It is second, 10, 12, 15, 18. These are the number of cards. Using this, we make this design. So once we make this design, what is our objective? To make a questionnaire. And after making a questionnaire, asks for this particular combination, give some marks. So after reading semi, 6 kg, front loading, 5-star, one can give 80. This is the utility, perceived utility he can derive out of 100 for this combination. This is the one way to collection of data. Another is, if make 20 cards, simple cards, just like a cards of hearts and diamonds is in the market. So you just make this type of cards and give them 20 cards. And what is your query? After reading the all combination in a card, please arrange the combinations according to your preference, highest to lowest. In that case, suppose out of 25 cards, he gives this as a 15 number. He gives this card as first, this card at second preference, this card at third preference. So you can collect data in two ways. One is simply the preference ordering. Sorry. And another is directly given the total 100, out of 100, how much you give for this combination. Clear? How to collect data? Is it clear to all of you? And this is the most vital thing in conjoint analysis. You have to make this first. And after making this, you are in a position to collect this type of data. And now see, this is the code corresponding to the each combinations. And using, when you ask question, you have to put this. If you put 2, 1, 1, 2, anyone is not able to answer. You have to give these combinations. And after getting the preference ordering of the number, just like here, see, I am using the preference ordering. So person 1 is the profile 1. Sorry, this is the profile 1. Profile 1 means this is the profile 1. First profile or the first card. This is the second card. This is the third card. This is the fourth card, right? This is the card number 20. So you ask that individual giving these 20 cards, please rearrange these cards according to your preference. And the individual one rearrange these. That profile 1 is 14. Profile 2 is 12. So according to him, the first preference card is profile 3. So what is profile 3? Just check. Semi 10 kg, top less than 10k, 5-star. Is semi-automatic 10 kg, top loading 5-star within less than 10k. So obviously, this is the first combination for that individual. He perceives if this combination he can buy, it gives him maximum utility. Similarly, individual 2 thinks card number 17 gives him the maximum utility 1, and card number 16 gives him the least utility, that is 20. So what is card number 1? Sorry, card number 17. This is the card number 17. Semi 8 kg, top loading 10 to 15k, 3-star. According to him, this is the combination. This combination gives him the maximum utility. So individual to individual, concept of utility, perception of utility differs. So if you ask this, here we collect the observations of total 17 individuals. And basically we are collecting this from you, from the participants of the previous workshop of this particular university, and on that workshop we collect this information regarding this washing machine case. So these are the information given by the participants of that particular workshop, right? So in this way, first you have to decide the number of cards. You have to make these cards combinations on the basis of the levels of each attributes. Then you are in a position to collect information. After that, you collect information. To run this in R language, you have to make an Excel sheet, one containing this preference ordering, and another is the code of the cards, 20 cards. So to make a worksheet containing these two sheets. Clear? So after collecting the information regarding the preference ordering of the each profile, you put the data in one sheet, and you already did, when you make your questionnaire, you already know the coding of this, you save this, and now you use this for your further analysis. So your data sheet, Excel sheet looks like this. One containing the coding, that is the design, another containing the preference ordering. So two data set, one is for preference, one is for profile. One for preference, one for profile. Clear? Up to this it is clear?
Yes, sir.
I am not giving you this particular data set. Why? Because in your workshop, there are 20 individuals. 20 to 25 participants are there. So already you are now in a position to derive these particular cards. My suggestion is, after the end of this class, you just, each of you just give the preference ordering for these 15 cards and collect the information for all other participants and make this particular data set. And then rerun the code that I now use for you. Clear? What is your task? If you are able to do this now, then conjoint analysis is very much easy to you. You already derived this. The code is given to you. You already derived this. So you just give some rank 1 to 20 of each combinations. So all of you give this and collaborate, collect from all other participants and make one particular dataset of your own, and then rerun the remaining codes. Calculate the part of its utilities and the total utilities of your own. So that's why I am not giving this particular data sheet to you. Any doubt? Any problem?
No, sir. I will try.
Not I will, you will try. This is the teamwork.
Oh, okay, sir. Okay, sir.
I think you have a WhatsApp group. You have a WhatsApp group or not?
Yes, sir.
So use this WhatsApp group for your study.
Oh,
So now, what we do here?
No,
Line number
I don't
21.
have a WhatsApp.
Pardon? Any query? Any query from you? From your side? Fine. So what do you do here? Use the library read Excel. Then we import the Excel file that I just show you. This file, sheet 2 containing the profile, sheet 1 containing the this, right? So once I run this, then we rename this. One is for preference and another for profile. So one is my preference file, another is my profile file. Clear? So the step 1, first we, with the help of these labels of each attribute, we derive the design, encode this, save this in a CSV file, calculate the information from the individuals regarding the utility. Then we make a single Excel sheet, Excel workbook, in which sheet 1 or sheet 2 either or contains profile and preference. Then we import this in R and rename these as preference and profile. You can directly name here preference profile, but I use this another name and here we change the name. Clear? Now you have to once again define the labels. So we just write the labels, all labels. You just see full, semi, 6 kg, 8 kg, 10 kg, font, top, etc. 5-star, 3-star. And then we make this label as a data frame. As I told you from the first class, please, when you do your data set, see the structure of the data set. If it is not data frame, make it data frame. Otherwise, it is not possible to run or performing any analysis in R. Clear? So we run this level, make it data frame. I will discuss line number 30 later. Before that, now we are in a position to perform the conjoint analysis. What are the arguments of the conjoint analysis? First, you have to write the name of the data set which containing the preference. Second, the profile. That's why I am writing here preference profile. One file named as the object as profile, preference, and next one is profile. And the label data set. Which are the labels? If you run this conjoint analysis, you see these are the diagrams. First, you see the diagram. What is this? Category, capacity, loading, price, energy. So among these 5 attributes, which one actually gives individual perceived from which most utility? Capacity. Next is energy. Next is price. Next is loading. Then is category. So category have lowest utility. So the researcher is now in a position to know which attributes actually have more utility. Or from which attribute individuals are perceived to be derived more utility. So here the result is capacity. Next is energy. From your own data, the result may vary. But for this particular case study, energy capacity is the highest utility. Then energy, price, and you see energy and price are more or less same. So if we go here, we just see these are the coefficient. I will discuss this after showing you the diagrams. Next is the diagrams for the energy. You just see utility is 0. So for 3-star it is positive utility. For 5-star it is negative utility. So for the labels of each attribute, now we consider the labels of each attribute. For energy, 3-star is a positive and 5-star is a negative. Price, for less than 10K, the highest utility. 15K to 20K utility is less than this, and for 10K to 15K, this is the negative utility. Utility is negative. Now loading. Similar interpretation. Capacity, it is similar interpretation. Now you see these are the utilities. Levels and utilities of the each levels. Full minus 1059, semi 1059. The thing is, if you add all, it actually 0. For any level or attributes, the 3 levels, suppose the 3 level, you just see, if you add all these 3, it is actually 0. 10399 plus 638 is equal to 1677. So plus minus it becomes 0. Clear? So what is our objective? To find out the partial utility or the part or utility of each attribute. So we are now able to find out the utility for each level as well as the total utility. If we add this, we can calculate the total utility. Clear up to this part? Clear up to this part? It is clear or not?
Yes, sir.
So now, what is line number 31? What do we write here? CA model. Oh, I have to change the fine. Wise preference 1, 1 to 0, and 1 by. That means we are considering 1 means first row of our data set. That means the first individual. If we run this, you see, this gives you the utility for the first individuals according to their preference. So according to first individual, the 2 category have this utility. Capacity 2 has this utility. Loading have this utility, price have this utility, price 2 have this utility, and energy has this utility. So using this command, particularly CA model, if we put here 1, it gives you the individual one's partial utility. That is, you can also able to derive the utility of a in particular individual. If we change this 1 to, suppose we try to find out the 10th individual, just make it 10. If we run this, so it gives you the result for the 10th individual. Clear? Clear up to this? Then next, consider the line number 36. Here you use the command CA importance to find out the importance of the attributes. Which attribute is more important? If we run this, so this is the score for each attribute. 1, 2, 3, 4, 5. The first one is highest is 31. You already view this in a graph. The second is 27.23. The third is 24.87, 13.64, and 3.26. So these are the ordering of the attributes. Which attribute is most important? Clear? To find out the partial utility, either you can use this particular command, or if you use this command, share partial utilities, the arguments are same: preference data file name, profile data file name, and level data file name. If you run this is the partial utility. Just see for all individuals. So if we consider the individual 1, this is the partial utility derived by individual 1. From full, he is deriving 0.9. From semi minus 0.9. 6 kg is 1.202 and remaining these two. From 2.40 or automatically top is minus 2.20. Is 1.869 minus 3 point. Just consider this, the first row. Similarly, if we consider the ninth individual, that is the, you consider this row. So you can easily calculate the part or utility for each individual also. So which individuals perceive what? Why this is required? Because when we use the market research for a particular product, what is our objective? Objective is clearly to find out the utilities. But among the individuals, among the customers, all the customers are not homogeneous. They are heterogeneous. So heterogeneity is there. So if with the help of their preference ordering, their perceived utility, we make this a homogeneous group, then our marketing strategy will develop among this homogeneous nature of customers, or we can uh, define a definite policy, implement definite policy for the homogeneous group of customers. So, or the different group of customers, which group is homogeneous among them. For this, we use this function, CS segmentation, and we try to make three groups. Three groups. This is basically concept of cluster analysis. So if we write this ACG CS segmentation, then the preference file name, profile file name, and C equal to 3. C equal to 3 means we are willing to create three groups. If we run this, then we use the library Facto Extra. The name of the library is Facto Extra. This is used for the cluster analysis. Then we define cars as seg is a function name of the variable seg SEGM. And each cluster is the function name of factor extra package. If we use this, you just see three groups are there. So one group is this, another group is this, and another group is this. So three groups are there. So this group is homogeneous group, this group is homogeneous group, and this group is homogeneous group. On the basis of their utility score, see what we write here: class, that is the this particular object, and the util, that is derived from the, already we show you the individual utility or partial utility. We stored this here at sec. The object name is sec, SEG. So if we do this, then these are the three homogeneous group or three clusters. So different policy marketing strategy will be developed on the basis of these distinct three groups. This group is totally different from this. This group is totally different from these two. So the customers of these groups have definite or definite preference level. So the product will design on the basis of the preference of this particular group of customers. This is another group. So there is some makeover of the product to attract this group of customers, and similarly for this one. Clear? Up to this it is clear. So I am from your chat box. You just copy the codes for the remaining part. So once you collect the data, you are able to run these particular codes. That is your task. Any query, any problem up to this, or it is okay to all of you?
Yes, sir, it's okay.
So for conjoint analysis, we stop here. So now if you have any problem regarding factor analysis, please tell. If you have any problem regarding factor analysis, please tell.
Sir, I was having a problem in running that code. I told you earlier, but I tried once again. It
You are facing problem in which line?
second, but it ran, sir, because there was some gap. So I just corrected those gap, and it ran successfully.
So
So I
fine.
proceeded further. Yes, sir. Yes.
Fine. So anyone have any query? I am giving my mail ID to you in your chat box. If you have any problem, you can mail me. If I am able to answer this, I will definitely reply that mail. So thank you very much for listening me.